Math 2, Unit 12B. So this is continuing on what we've already learned. So guess what we're going to be dealing with more? Parabolas. Okay? So we have the standard form of a parabola, and in our last unit we found that sometimes we could factor it from standard form, which would give us the x-intercepts, and then we could find information from there. Remember that? Okay, well, there's actually kind of a shortcut sometimes for graphing, bless you, for graphing in standard form, and that is using this equation, and it is x equals negative b over 2a. Where does the negative b and 2a come from? The standard form equation. Very good. So you need to make sure that it's in this form where you have y equals on one side or 0 on one side, and then you have a, b, and c on the other side together, okay, in descending order. So remember that a always goes with x squared, b always goes with the x term, and c is always the number that doesn't have a letter with it. Okay, and so this is your vertex. You can find when it's in standard form. And so you find the x value of the vertex by negative b over 2a. Once you get the x value, you substitute the x value in and then simplify to find y. Okay? So this first problem right here, it says graph this function. Okay? Let's go ahead and first state what are my a, b, and c values. What would a equal? Negative 1. B is going to be positive 4, and C is negative 2. Now, whenever I am using this method, I always write my equation because it helps me remember it. And so that is x equals negative b over 2a. And then I'll plug in the values. What does negative b mean? It means the opposite of whatever b is. So if b is positive 4, negative b is going to be negative 4. And it goes back and forth, right? So if you had a negative number, the opposite of it would be a positive. Okay? Over 2 times, and what is a? Negative 1. So we end up with negative 4 over negative 2, which simplifies to be, very good, positive 2. So for my vertex right now, I know that the x value of the vertex is 2. Okay, and we did do this back in 12a as well. Once you know the x value of the vertex, you can find the y value by just plugging it into your equation. Okay, and so my equation is right here, correct? So to find the y, we're going to write y equals, and we're going to plug in 2 for x. So we have negative, and then this is 2 squared. The negative is not what x is. So the negative's in front. So be careful of this because when we're squaring this, we're going to square a positive 2, which will end up making this a negative 4. If I was plugging in a negative 2, then I'd be squaring a negative 2. But this negative's in front, so it's separate from being squared. Is that clear? Okay. So, and then I have plus 4 times 2 minus 2. And so 2 squared we just said was 4, so I end up with negative 4, plus 4 times 2 is 8 minus 2. And then negative 4 plus 8 is 4, and 4 minus 2 is 2. So that means my vertex is 2, 2. Okay. The other thing that is nice about this form is that it will always give you your y-intercept value. Okay, so if I am finding my y-intercept value, I'm going to write this as y-intercept. All you have to do is plug in 0 for x's and simplify, and you find your y. So if I have negative 0 squared plus 4 times 0 minus 2, you end up getting 0 plus 0 minus 2, which is just negative 2. So my y-intercept is 0, negative 2. So I have 2 points here now I can plot. And the y-intercept, it is always like whenever you plug in 0 for x's, these all go away. So when it's in standard form, your y-intercept's always the number that doesn't have a letter with it. Okay, so we're going to have to make our coordinate plane. And so we're going to draw 2 lines there. So you want to draw your x and y axis somewhere on here. Okay, and so my vertex is at 2, 2, so I'm going to go right 2, up 2. And then my y-intercept is at 0, negative 2, so I'm going to go down there. And then I know this is my vertex, so it just is curving down. And by having that y-intercept, it just helps me have it a little bit more accurate. It also, because this was a vertex, showed me that the graph is going down. And we know it should be going down because my a value is negative. Okay, any questions so far? All right, so let's go to number 1. And we're gonna try to do this again. First of all, before I do anything, do you guys know what my y-intercept would be? Right, if you plugged in 0 for these, you'd end up getting positive 9. Good. So my y-intercept value is at 0, 9. Are we good with that? Okay, now we're gonna find our vertex. How do I find the x value of the vertex? Negative b over 2a. I'm going to start by writing that. And so we know that this is my a, this is my b, this is my c. So negative b is going to be what again? Good. Negative 8, because right now it's a positive 8, so we do the opposite. And then a is 2 times negative 2. So we get negative 8 over negative 4, which makes a positive 2. Okay, so somewhere I'm just going to kind of put it separate. I'm going to put my vertex, and my vertex is positive 2. And then I still need to find my y value. How do I find my y value? Very good. So we have y equals, and we're going to have negative 2 times 2 squared plus 8 times 2 plus 9. So you always do exponents first. 2 squared makes 4. Negative 2 times 4 makes negative 8. Good. 8 times 2 is 16. And then we have plus 9. So we have 8 plus 9, which is 17. So that means my vertex is at 2, 17. Now, in terms of graphing, this is going to be a little bit off the graph. But I'm going to go ahead and make it way down here for my x and y intercepts since I have to go so far on the y-axis. You could also count by like 2s and see if that's helpful. Or you could just make a mark and say this is 17. If I go by 2s, let's see here, 2, 4, 6, 8, 10, 12, 14, 16. So that'll work, 17. So I'm going to do 2, 17 like that. And if you do end up going like by 2s, you kind of want to mark a few of them so that the person that's looking at your graph will know that you went by 2s. And then for y-intercept, it's at 0, 9. So if that's 6, this is 8, so 9 would be about right there. And does it make sense that this one would also be going down? Yeah. Yes. Okay, any questions? All right, this next one, we're gonna end up getting a decimal, which is okay, and you can use calculators. But I was gonna have you do it on your own, but because it turns out it's a decimal, we're gonna go ahead and do it together. Okay, so first of all, where would be my y-intercept point?
0, 1.
0, 1. Is anybody confused by how we're getting those numbers? So if you were to plug in 0 here for x, so if I did y equals, and you have 2 times 0 squared minus 6 times 0 plus 1, 0 squared is 0, 2 times 0 is 0, minus 6 times 0 is 0, plus 1, so you get 1. So anything that has like an x with it, when you plug in 0 for x, it goes away. And so when it's written in standard form, you know your y-intercept ends up being that last value. Is that better?
Is it always 0 is plugging 0?
Yes, for your y-intercept. X, because you're on your y-intercept, x is 0, and then you find your y value. Okay, any other questions so far? Okay, and then for my vertex, how do I find the x value of the vertex? What's the equation? Very good. Negative b over 2a is correct. And so what is negative b? Okay, so this is A, B, and C. And make sure you pay attention to the signs in front. Yeah, so since right now b is negative 6, that means negative b would be positive 6 over 2 times 2. And we get 6 divided by 4. And I'm just going to go ahead and change that to a decimal. And does anybody know what that is as a decimal? 1.5 or 1.5. Good. So we have 1.5. Okay, from there now, how do I find the y? Plug it in. And luckily, we get to use calculators, so it makes our life a little bit easier when dealing with decimals because we can just plug in numbers. So 1.5 squared. And you get a number, and then you multiply that number by 2. And you should get 4.5. If you're using your calculators.
4.5.
Do you agree? Okay. And then you multiply. Do you guys agree with me or no? Okay. And then what is minus 6 times 1.5? 9. Yeah, good. Minus 9 plus 1. And so again, if you feel more comfortable, you can type that into your calculator and you can go 4.5 minus 9 plus 1, and it equals
5.5. Altogether. 4.5 plus 1 is 5.5.
is 5 point. Okay, it is 5.5.
Yeah, like the whole thing.
Okay. I think I disagree. So hold on. It's negative 3.5, right? Because you have a negative. I'm like, okay. Yeah, negative 3.5 is correct. I didn't think that was right. Okay. So you can again plug it in. Do you want me to show you in the calculator? You can actually just plug it in like this too. But you go 4.5 minus 9 and then add 1. And 4.5 minus 9 is going to give you a negative.
I did 9 minus 4.5.
There you go. Okay. So when we go plot this, we need to first make our x and y axis. So 1.5 is in between 1 and 2. And then we're going to go down 3.5. So 1, 2, 3.5, which would be between negative 3 and negative 4. And then 0, 1 is my y-intercept. And so then you can draw your parabola. Okay, questions? Okay, sports. A baseball is thrown into the air with an upward velocity of 30 feet per second. Its height h in feet after t seconds is given by this function that is right here. How long will it take the ball to reach the maximum height? And what is the ball's maximum height? And then what is the range of the function? Okay, so where does our maximum height come from? How do we find it? It comes from our, so it's at a V, our vertex, right? And so how would I find my vertex? X equals negative V over
2a.
Thank you. You guys can do this. All right, so my A value is negative 16, my B value is 30, and my C value is positive 6. So what will be negative B? negative 30 divided by 2 times negative 16. Negative 30 over negative 32 is correct. And when you divide that into your calculator, let's round that to like the nearest hundredth. What do you get?
I got 0.9375.
So to the nearest hundredth, 0.94, and that's actually in seconds. So we're going to just write our vertex here. So our x value of the vertex is 0.94. How do I find the y? Or the h? Yeah, plug it in. I'm just going to do y. You could do h, however you want to. So we have negative 16 times 0.94 squared plus 30 times 0.94 plus 6. So in your calculators, you first need to take care of the square. So you type in 0.94 and square it. And then once you square it, I would just keep that value in there and then multiply by negative 16. And what do you get?
14.1.
Good. So that'll be negative 14.1. And then 30 times 0.94. I think I heard somebody say it. 28.2. And then plus 6. And so then again in your calculator, you can do negative 14.1 plus 28.2 plus 6, and that equals 20.1, and that's in terms of feet. So my vertex is 0.94 and 20.1. So they asked me, how long will it take the ball to reach the maximum height? 0.94 seconds. What is the ball's maximum height? 20.1 feet. And then it says, what is the range of the function? Now, would this parabola be going up or down, like curving? Down, because the a value is negative, right? So this one would curve like this. So what would the range be if it's curving like that?
Greater than or equal to 0.
It's curving down. Yes. Okay, and so we could put y is less than or equal to 20.1, but more specifically, actually on this one, could the ball go below ground? So it's going to be 0 is greater than or equal to y is greater than or equal to 20.1. Because basically it's saying that your values are between 0 and 20.1. Okay? Questions? So like here, I didn't draw an accurate thing, but the ball can only go up and it would only go down to the ground. So that means that y is in between 0 and 20.1. So if this was like your x and y plane, this is 0.
I'm just confused why you put 0 is greater than y.
This, when you write it like this is meaning that the value has to be greater than 0. And this means, or did I do this the opposite?
Yeah, I think it's supposed to go the other way.
Yeah,
It's supposed to be
y is
0
supposed to be
is
less than or equal to
y is
21.
less than.
Thank you. There we go. Good job, Shelby.
Thanks.
Okay, there you go. Does that look better? Thank you. Okay, and so this one's not correct. Correct?
Correct.
And why is this one not okay? Because then it's saying that the ball can go below ground and balls have to be at ground level. Okay. All right. Are we good to move on? Yes? Okay. Okay, so we have our school fair. Suppose you have 100 feet of string to rope off a rectangular section for a bake sale. Okay, the function is given by area equals negative x squared plus 50x. Okay, and that gives the area section in square feet, where x is the width in feet. What width gives you the maximum area you can rope off, and then what is the maximum area, and then what is the range? So guess what? This is just like the last one. What information do we always need when we're finding maximum and all that stuff? The vertex, okay? And so we know we need to find the vertex. So how do I find the vertex? X equals negative b over 2a. So in this problem, what does a equal?
Negative X.
Negative 1. What does b equal? And what does c equal? 0. Okay. So negative b would give me
1.
negative 50 over 2 times negative 1. So we get negative 50 divided by negative 2, which makes 25. Okay? 25 goes in for the x value. What did they say x was? If you look back in the question. The width. So 25 feet is for the width. Okay? And then next, we are going to find the y value or the area value. And how do I do that? Good. So I'm going to do y equals, you could put a equals, and you have negative and then 25 squared plus 50 times 25. Remember that that negative is not part of what's being squared. If you type into your calculators, 25 squared equals, so negative 625 plus, and what's 50 times 25?
75.
1,250 is correct. And when you add those together, you get 625 feet squared, which is your maximum area. Okay? Now, how are we going to write the range on this one based on what we learned from the last example?
0 is less than or equal to the y. Which is what's going to be 0 to 625.
Perfect. And I put y here, and I just realized even we could put a or y, okay, but this is going to be our range. Okay? Any questions? All right. We are just going to do 2 more examples. We're not going to do all 4 of these because I don't think you guys need them. I would like you to try to do number 1 on your own. So I just want you to state what your vertex is and your y-intercept and graph it. And I would be happy to take a volunteer for someone to come up and do it if they want to.
Wait, which 2 are we doing?
So we're gonna just do the top 2. Okay. Do you have a volunteer that someone wants to come up and do this problem? Nobody wants to today? Do you guys need more time? Or are we good? Good?
Do I get candy?
Yeah. You want to do it? Okay. What? Yeah, oh yeah, you can start on the next one if you want to, but okay, Robert's going to go through this problem. Okay, so the first thing he's going to do is find out what the x value of the vertex is. And he finds that by x equals negative b over 2a. I appreciate how he wrote the equation. You can always label A, B, and C, but a lot of you know A, B, and C already, and you don't need to label them, which is fine. You don't have to. And so negative B gives him a positive 4 over 2 times 1, because A is 1, and that reduced to be 2. So now he's going to plug the value of 2 back into his equation to find the y value. And so he gets 2 squared minus 4 times 2 plus 1. He knows that you always have to do exponents first. So 2 squared is 4. Minus 4 times 2 was 8 plus 1. And then simplifying, he gets negative 4 plus 1, which is negative 3. So he has his vertex. So now he's going to draw his x and y plane. And so for 2, negative 3, he goes right 2, down negative 3. He plotted his y-intercept, and if he plugged in 0 for those values, he knew the y-intercept was 1. Perfect. You can get it handy too if you want. Yes? Very nicely done. Okay. Are there questions here on this problem? Okay, number 2. Looks like a lot of you already had a head start on that one. Do I have a volunteer to come up and do number 2?
We need more time.
More time still? Okay. Do you want to do number 2? So, okay, give me a thumbs up if you're done.
I'm not done.
All right, I'll give you another minute. Okay, so still no volunteers for this one? Yes, Michael, you're going to do it? Okay, come on up.
Okay.
Okay, so good. So Michael also starts with writing his formula, which I suggest you always do, because then hopefully you won't mess up. And so negative b is the opposite of e, which is 8, over 2 times a, which happens to be negative 2. So you simplify that, and you end up getting negative 2. Okay, I'm just going to move it. I'm just going to move it. Okay, so next, in order to find the y value of the vertex, he needs to plug in negative 2 into the equation. So negative 2 times negative 2 squared minus 8 times negative 2 minus 3. And then Michael's super smart. He knows that you always do exponents first. Negative 2 squared is positive 4. Negative 8 times negative 2 is positive 16. Good. Okay, so the negative 8 plus 16 is 8. Minus 3 makes 5. So that means the vertex is negative 2, 5. And then we want one more point. And so an easy point to get is our y-intercept. We find that by plugging in 0 for x. And he found the y-intercept is at 0, negative 3. So now he's just going to make his x and y axis and plot his 2 points. What direction should this graph end up going?
Down.
down. And how do we know it's going down?
Because A has a negative.
Very good. A is negative. But when I plot these 2 points, my vertex and my y-intercept, it will automatically make it so that the graph is going down. And I don't even actually have to think about it very much. So, there it is. Very nicely done. And do we have any questions? Thank you, Michael. Okay. No questions? All right.